All right, guys, today we are going to work for grade 5, module 3, lesson 10. Now remember, you should have done the homework before. I'm here to help you with it. We're working with adding mixed numbers with unlike denominators. So the fractions are going to have unlike denominators here, right? So we know that when we have an unlike denominator, we have to find common parts to add them together, right? So the first problem is 2.5 plus 1 1/5. So we know that halves and fifths are not the same. Write it this way. And the reason that I like to write it vertically is because I'm going to do a little work common. So I count by the larger number and I say to myself, okay, if I count by fives, when am I going to find a multiplication answer that also works with 2? 5, 10. Oh, I know 2 times 5 is 10. So I'm going to make both of them into tenths. So tenths, I have to multiply by 2. And whatever I do to the bottom, I have to do to the top, right? Because 2 halves is really equal to 1. So we're not changing the value, we're just changing the fraction. 2 times 1 is 2. 2 times 5 is 10. So I have to multiply the top by 5. 5 tenths. Now I can add it all up. 5, 6, 7 tenths. And don't forget the whole numbers. All right, 2.5 plus 1 3/5. Well, we just did fifths and halves. So I'm going to change that and multiply by 2 halves, or 1, and give us 6 tenths on the bottom, 5 tenths on the top. Now, when I add all of this up, we're going to notice 5 plus 6 is 11 tenths, right? And over here we have 2 and 1, which is 3 tenths. So when we have the numerator that is larger than the denominator, we know that we can make another whole out of that, right? So 11 tenths is really equal to 1 1/10. Why? Because plus 1/10 equals 11 tenths, right? So we're going to add this to that, to the 3 that we had, and our answer is going to be 4 and my circle. All right, C. 1 1/5 plus 3, 5, and we have 3. So I'm thinking to myself, 5, 10, 3 times nothing, not a whole number, equals 10. So I'm going to keep going, counting by fives. 15. I know 3 times 5 is 15. 3 times 5 is 15. So 1 times 5 is 5. And 5 times 3 is 15. And 1 times 3 is 3. I'm going to add those up. 3 plus 5 is 8. The denominator stays the same. 3 and 1 is 4. So our answer, 4 8/15. 2/3 plus 1 3/5. Right? Now again, we just did 15 times 3 is 9. 3 times 5 is 15. 2 is that up here. 10 plus 9 is 19/15. And over here we have the 3 plus 1, which is the 4 for the whole number. So we can take out 15/15, right? Because 19/15 is the same as 15/15 plus 4/15, and this 1 and add it to there, that's really equal to 5 and 4/15. All right, let's take a look at E. E is 2 1/3. Now we have a different denominator, 4 4/7. I'm going to count by the larger number, and I'm going to count 7, 14. Well, there's not a number that you can multiply 3 by to equal 14. That's a whole number. 21. 3 times 7 is 21. So we're going to make this into 21st. 4 times 3 is 12. 3 times 7 is 21. So 1 times 7 is 7. 19, 21st. 4 plus 2 is 6. So that's our answer for that one. It's 3 5/7 and 4 2/3. We can see that the same thing's going to happen here. We have 21st that it would be, and then we're going to multiply by 21, by 7 to get 14, by 3 to get 21, by 3 to get 15, and we're going to have, well, I know that that equals 21 21st plus 8 21st, right? This equals 1. 7 plus the one I have here plus 8 21st, or 8 and 8 21st. Okay, let's go on to G. Okay, G, 15 1/5 plus 4 3/8. So the same thing, I'm going to write it vertically so that I can do the work a little easier and organize myself. And I'm going to think about, if I count by eighths, what number will they both have in common? I'm looking for a common denominator. So I'm going to say to myself, well, 5 doesn't become 8 using whole numbers. 16, no, it doesn't become, it doesn't end in 5 or 0, right? 16, 24, no. 32, no. 40. 8 and 5 both can become 40 using multiplication of whole numbers. Now, you might be saying, hey, can't I just always multiply these two? That is a strategy that works, right? If we go back to the other page, 3 times 5 is 15. 7 times 3 is 21. 5 times 3 is 15. 7 times 3 is 21. So yes, they always have common denominators, but this is a good practice to find the lowest common denominator, and we'll talk about that later. But let's go ahead and turn it into 40ths. 8 times 5 is 40, so 3 times 5 is 15. 5 times 8 is 40, so 1 times 8 is 8. We're going to add those up. 15 plus 8 is 23/4. And over here, we have 15 plus 4, which is 19. So our answer is 19 23/4. All right, 18 3/8. I'm going to rewrite it so that I have some space to do my work. And again, we're going to have the same common denominator as the other problem. 8 and 5 can become 40. Notice I'm also writing way over here so that I have space sort of to do my work in the middle. When you write it right next to each other, it's a little bit, gets a little confusing and jammed up. So we're going to write times 8, which gives us 16, and 8 times 5 is 40, and 3 times 5 is 15. So that's going to give me 6 and 5 is 31/4 plus the 18 and 2, which is going to give us 20 and 31/4. All right, great. Now, let's move on to the word problems. Angela practiced 2 1/3 hours on Saturday and 3 2/3 hours on Sunday. How much did Angela practice piano during the week? Well, we're going to add all of those together, and we're going to need to find a common denominator. Now, we can see here that we're going to have thirds and thirds. So when we look at this, if I count by threes, 3, 2 can't become 6. So we're going to make common denominators of 6's, right? So times 2 is 6, times 2 is 4, times, and this one times 3 is 6, so times 3 is 3. Now we're just going to go 5, 6, 7, 8, 9, 6, and don't forget the whole numbers, 3, 4, 5, 6, 7. So we have 7 and 9, 6. Remember that 6, 6 equals 1. We're going to add this 1 to the 7, which is going to give us 8. And if we take away 6, 6, we're going to by it, right? And we can say, well, we know 3, 6 is actually 1/2. Okay, so we're going to circle our. Let's take a look at number 3. String A is 3 5/6 meters long. String B is 2 1/4 meters long. What strings? Well, we can do this 2 ways. I'm going to make a tape diagram, and I know A is a little bit longer than B. So I know A is 3 5/6, and I know B is 2 1/4. So the question is, what are they all together? 3 5/6 plus 2 1/4. Now again, I'm going to think about my 6 and 4. I could just say, oh, this is 6 times 4, so my the multiples of 6. 6, 4 can't become 6. 12, 4 can become 12. So I'm going to go ahead and use 12, right? And if I count by 4s, 4, 8, 12. You see how they both have 12 as their lowest common denominator? So it's the number that they have that's in common that is the smallest. Okay, and then we're going to go ahead and just solve the problem. 6 times 2 is 12. 5 times 2 is 10. We're going to go ahead and add this up. We get 13 twelfths, and the whole numbers 3 and 2. 12 twelfths equals 1. So we're going to make this 6, because the 5 plus the 1 is 6. And then we're going to take out this 12 twelfths, and we're going to have an answer of 6 1/12. That is our answer. So length of both strings is, I just squeeze that in, okay? All right, and the last one today. Matt says that 5 minus 1 and 1/4 will be more than 4. Since 5 minus 1 is 4, draw a picture to prove that Matt is wrong. So there are a couple things we could do. 2, 3, 4, 5, right? Those are 5 things. And then it says we're going to label this as 5, right? And then we're going to take away 1 and 1/4, right? So we're going to have to go 1, we're going to have to split 1/4. So when we take away 1 and 1/4, what are we left with? 1, 2, 3. 1/4, 2/4, 3/4, right? So we are left with whatever equals 3 and 3/4. So for Matt, the picture shows the answer is 3 and 3/4. Okay, so that is the homework for lesson. Subscribe and come on back for the next lesson.